In this lesson, we will look at an economic application of functions. The problem. Katie and Sue are setting up a lemonade stand. Their mother is supplying lemonade in paper cups, but will charge them $5 for the lemonade and 5 cents for each paper cup that they use. How many cups of lemonade will Katie and Sue need to sell to make a profit of $10? To solve the problem, we need to know: what will Katie and Sue charge customers for each cup of lemonade? Well, Sue thinks 50 cents will be the most they can charge without scaring off customers, so Katie and Sue decide to sell lemonade for 50 cents per cup. The solution: an algebraic approach. And we are using algebra here, although we might be able to solve this problem by just thinking it through. We will use economic functions to find a solution, starting with a function that will represent the price. By definition, if x represents the quantity of items produced and sold, the price demand function, lowercase p of x, calculates the price per item. What function represents Katie and Sue's price? The price of each cup of lemonade will be 50 cents or $0.5, and we'll convert everything to dollars in this problem to make things easier. The number of cups sold does not change the price, so the price demand function will be p of x equals 0.5. Notice that there are no x's in this function. In some price demand functions, the price will change according to the number of items sold, so you might have, for example, p of x equals 0.5x, but not in this case. What function represents the amount earned from sales? The amount of money received from sales to customers is the revenue. By definition, the revenue function, r of x, equals x times p of x, the price demand function. This calculates the total money collected by selling x items. Katie and Sue's revenue function: if Katie and Sue sell x cups of lemonade, they will collect x times $0.5. So their revenue function, r of x, equals x times 0.5. Let's check to make sure this makes sense. Say they sell 10 cups of lemonade. Their revenue would be 10 times 0.5, which would be $5. Does that make sense? Sure. Okay, so let's look at what function represents the cash needed to produce the items that will be sold. This includes supplies and other necessary setup costs, such as lemonade and cups in this case. By definition, the cost function, c of x, calculates the cost to produce x items, the x items in this case being the number of cups of lemonade. Katie and Sue's cost function: it will cost Katie and Sue $5 for the lemonade and $0.05 for each cup sold. If they sell x cups of lemonade, the cost will be the cost function, c of x equals 5 plus 0.05x. If no lemonade is sold, the cost is still $5. This is the fixed or startup cost, c of 0, and note in this case, if we plug 0 in for x, c of 0 would be equal to 5 plus 0.05 times 0, which would give us 5, and the 5 is the cost of the lemonade that they'll need to pay regardless of number of cups sold. What function represents the amount of money left after payment has been received from customers and costs have been deducted? By definition, this is the profit. The profit function, uppercase p of x, equals r of x minus c of x, the revenue minus the cost. The profit function calculates the money earned after costs are paid when x items are produced and sold. Katie and Sue's profit. How much money will Katie and Sue have after they pay for the lemonade in cups? This is their profit. Katie and Sue's profit is their revenue minus cost, just like we saw by the definition. So Katie and Sue's profit function is going to be R of X minus C of X. And if we remember, R of X for Katie and Sue was X times 0.5 minus C of X. Their cost function was 5 plus 0.05X. We simplify to get a profit function of 0.45X minus 5. So this is Katie and Sue's profit function. The solution. Okay, so think of the original problem. What were we trying to find? We were trying to find how many cups of lemonade they needed to sell for a profit of $10. Okay, so if we set their profit equal to $10 and simplify, we have 0.45x minus 5 equals 10. This simplifies by adding 5 to each side to 0.45x equals 15. We will divide through by 0.45, and that results in the number of cups, x, being equal to 33 1/3. So Katie and Sue should sell 34 cups of lemonade, being that if they only sell a third cup, you know, they really can't do that. So, well, I guess they could. But anyway, they will need to actually sell 34 cups of lemonade to make $10. We might also want to know here, what is the cost of each cup of lemonade that is sold? We use the average cost function to answer this question. We know that the price per cup of lemonade is 50 cents, but how much does it cost to produce each of those cups of lemonade? So the average cost function, by definition, is C bar of X equals C of X over X. So it's the cost function divided by X. This calculates the cost per item when making X items, assuming X is greater than 0. So let's see if we can use this function to determine the cost per cup of lemonade. For Katie and Sue, the average cost is going to be C bar of X equals their cost function, 5 plus 0.05X, divided by X, the number of cups of lemonade. If they sell 34 cups of lemonade, which they would do to make their $10, the cost per cup will be 5 plus 0.05 times 34 divided by 34, which is approximately equal to 19.7 cents per cup. And notice if they sold a different number of cups of lemonade, that this would change a little bit. So the cost per cup is dependent on the number of cups that are sold. Here's one to try on your own. Katie and Sue's mother charges $5 for lemonade and 10 cents per paper cup. Katie and Sue sell lemonade for $1 per cup. How many cups of lemonade must be sold to make a profit of $15?